As we start Chapter 5 with Section 1, we're going to talk about quotients of monomials. And this is pursuing Algebra 2 State Standard number 7, where we're going to add, subtract, multiply, and divide. But for today, we're not doing the blue, just working on the red. Starting to reduce, evaluate rational expressions with monomials. So that's where we're starting today. We'll pick up the polynomials in a little bit. What we need to do is to remind you about multiplication, that if a, b, c, and d are real numbers and b cannot be 0, d can also not be 0. That's because they're the denominators. That if we have a fraction or a rational number a over b times another fraction or rational number c over d, we can multiply the numerators a times c, put that over the product of our denominators b times d. So that's an important reminder. And then when we're simplifying rational expressions, if we have a, b, and r are real numbers, again, b can't be 0, r can't be 0 because they're in the denominator. If we have some number a times another factor r over number b times another factor r, any factors that are the same in the numerator and denominator divide out to 1 and allow us to simplify and reduce our fraction to just a over b. With those in mind, we're going to start simplifying, and we'll start out with a numerical example so that we recall easily before we start with any algebraic examples. So 36 over 48, if we do a factor tree on that and then list all our possible factors, 36 could be, of course, 9 times 4, 9 is 3 times 3, 4 is 2 times 2. 48, when all is said and done, is 16, which is 2 times 2 times 2 times 2 times 3. So once we have our list of all the factors in the numerator and all the factors in the denominator, any factors that are the same in the numerator and denominator divide out to 1. So this 2 over that 2 divide out to 1. The next 2 over the numerator and the 2 in the denominator divide out to 1. There's a 3 in the numerator and a 3 in the denominator that are factors that divide out to 1 also. And then what's left, we pick up the survivors, I kind of call it. There's a factor of 3 left in the numerator and 2 times 2, or 4, left in the denominator. So that's using our simplification of rational expressions property and simplifying 36/48, reducing it down to 3/4. The important thing to remember here is that these must be factors, numbers that are being multiplied. They are not terms, numbers that are being added or subtracted. An important distinction to remember. So we need to reduce or simplify our factors. You cannot divide out and cancel out any terms that are the same in the numerator and denominator. All right, let's look at one that's similar, only has some variables in it. So we've got a monomial divided by a monomial as part of our goal today. 36 is 2 times 2, which is 4, times 9, which is 3 times 3. X cubed, for now I'm going to write that as x times x times x. Y to the 5th, for now we're going to write that as y times y times y times y times y. In the denominator, 27 is 3 cubed, or 3 times 3 times 3. X is x, y cubed is y times y times y. And we're going to do the same thing, looking for factors in the numerator and denominator that are the same. We have a factor of a 3, that'll divide out to 1. We have another factor of 3 that'll divide out to 1. We have a factor of x that'll divide out to 1. We have a factor of y that will divide to 1. We have another factor of y and yet another factor of y that'll divide out to 1. So what we want to do now is to look and see what's left in the numerator. That leaves us 2 times 2, or 4, x times x, which is x squared, y times y, which is y squared. In the denominator, all that's left is 3. Now, we'll learn some shortcuts and do some reminders, but that's the definition of being able to factor the numerator completely, factor the denominator completely, reduce any factors, not terms. Now, not too long ago in Chapter 4, we learned some laws of exponents. So here's the fine print again. M and N still represent positive integers. A and B represent real numbers. However, when we can't have A and B becoming 0 when they're in the denominator. All right, we had this property of exponents. When you're multiplying and the bases are the same, keep the base, don't change it, add the exponents. We still need to remember that in Chapter 5, even though we learned it in Chapter 4. Again, when you have a product being raised to a power, you can raise the first factor to that power, the second factor to that power, and then multiply the end result. Third, if you have a base raised to a power and that in turn is raised to a power, you keep the base, don't change it, multiply the exponent, so in this case that's m times n. Now those are the same three laws of exponents we've previously learned, so let's expand upon them. If the exponent of our numerator is larger than the exponent of our denominator, then this is true. When we're dividing and the bases are the same, keep the base, subtract the exponents m minus n. And in this case, that's only when m, the exponent in the numerator, is larger than n, the exponent in the denominator. What do we do if that's not true? Well, if that's not true, if the numerator's exponent is smaller than the denominator's, we're dividing and the bases are the same, it's 1 over the base, and we take the larger exponent minus the smaller exponent, and we end up with the reciprocal. Alright, and another law of exponents, when you have a fraction or rational number raised to a power, you can take the numerator and raise it to that power. Take the denominator, raise it to the power, and then divide the end results. So this one is very similar to when you have a product raised to a power. You can raise each factor to the power and then multiply. When you have a quotient, the end result from dividing, you can take the numerator raised to the power and the denominator raised to that power. Alright, we're going to take these laws of exponents and we're going to put them to use in the following examples. When I have 3 to the 7th divided by 3 to the 4th power, no longer do I need to list 7 3's in the numerator and 4 3's in the denominator. I can say the properties of exponents, and let's bring it back right here, that when I am dividing and the bases are the same, which they are, we keep the base and subtract the exponents. In the case where the larger exponent's in the numerator, then it's just 7 minus 4. And 7 minus 4 is 3. 3 to the 3rd power is 27. So there's this law of exponents. When you're dividing, the bases are the same. Keep the base, subtract the exponents, large minus small. If the numerator's exponent is larger, then we don't have to take the reciprocal of the number. Alright, let's look at another example. So we have 7y to the 5th over 1y to the 7th. And of course, 7 divided by 1 is just 7 in the numerator. And the property here, I don't think can't get them to fit. But the other law of exponents said when the larger exponent is in the denominator, and you're dividing and the bases are the same, keep the base but put it in the denominator of the fraction. And then subtract large minus small exponents. So 7 minus 5. 7 minus 5 is 2, so my answer is 7 over y squared. If you can visualize in your mind, you would have 5 y's listed out as factors, 7 y's listed out as factors. All the factors that would divide out, you would be left with 2 y's in the denominator. That would be the long way. But we prefer that you practice the laws of exponents that we're learning in this particular section. Alright, we have a rational number or a fraction raised to a power. We can also call it a quotient. We're going to take the numerator and raise it to that power. So x squared is going to get cubed. But then the denominator, so y cubed is going to get cubed. And then we need to simplify that. When you have a base raised to a power and that in turn is raised to another power, you keep the base and multiply the exponents. 2 times 3, which is 6. Y cubed quantity cubed, you keep the y, multiply the exponents. 3 times 3 is 9. So for this one, it simplifies to x to the 6th power over y to the 9th. Alright, let's look at another one where we have a monomial quantity cubed over another monomial quantity squared. To simplify this, we're going to take x and cube it. We're going to take the y squared and cube that. We're going to take the z cubed and cube that. In the denominator, we're going to take the x squared and square that. The y cubed and square that. The z to the 4th and square that. So let's simplify our exponents. That's x to the 3rd. Y squared cubed, 2 times 3 is y to the 6th. z cubed cubed. 3 times 3 will be z to the 9th. X squared squared. 2 times 2 is x to the 4th. Y cubed squared. 3 times 2 is y to the 6th. And z to the 4th squared. 4 times 2 is z to the 8th. Now, when we're dividing, and the bases are the same, which they are, we're going to keep the bases and subtract the exponents. So we have x to the 3rd over x to the 4th. That's going to give us an x to the 1st in the denominator. Y to the 6th divided by y to the 6th, well, anything divided by itself is 1. So I don't have any y's left here because they divided out to 1. Z to the 9th divided by z to the 8th. I keep the z in the numerator because there's more z's in the numerator. 9 minus 8 is 1. So all of that simplifies to z to the 1st power over x to the 1st power. So it's important we know those laws of exponents. We're going to use them this chapter and in future chapters to come.